Hello, everyone. Welcome. Thank you for joining this session. My name is Isabel. I am an event planner for the Microsoft Reactor, joining you live this morning from Sydney, Australia. Now, before we begin this fantastic session, we have a quick housekeeping. We are committed to fostering a welcoming, inclusive, and supportive environment for both our audience and presenters. While we absolutely encourage engagement in the chat, please let's keep our comments respectful and constructive throughout this session. This session is being recorded and will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. Thank you all for joining us on this session called Cloud Networks on Cruise Control with Azure Virtual Network Manager. I am excited to introduce our fantastic speakers and will now be handing over the spotlight to the first one. Take it away, Nirmal.
Awesome, Isabel. Thank you so much. Hello, everyone. Thank you for joining this session. So today we are going to talk about Virtual Network Manager, and we are also going to talk about some of the capabilities, challenges that we are able to solve through Virtual Network Manager. So to kick things off, what I'm going to do is I'm going to talk about customer scenario. So this is a large organization. So I'm taking a use case that is within Microsoft. So with larger environments, what typically happens is management becomes complex, especially when we think about 160,000 staff members, thousands of virtual networks. And then when we look at how do we govern, how do we control, how do we manage, we need to have an approach to ensure we have better governance and also at the same time an approach where we can enforce security as needed across the entire landscape. So this is a use case that is published as a case study used here at Microsoft, where we've looked at multiple different approaches on how do we manage virtual networks, applications at scale. So the approaches we've looked at is, can we manage VNets and also security centralized? What does that look like? Can we manage security and network rules decentralized? What does that look like? And can we effectively have a hybrid approach, and what does that look like? So typically what we find is when we have a centralized management, either leveraging some sort of a CI/CD or a deployment pipeline, all of the security controls, network controls are centralized. Each of the application owners would need to make a request and get a centralized team to allow certain security rules as needed. The drawback in this approach is that it is going to slow down pace of innovation, slow down how we release services, release products into the market. So not ideal for large environments, large customers. When they have this centralized approach, you are effectively spending a lot of time needing to request another team to approve, deny, allow rules as requested to have access within the application landscapes. Now, the other approach is to have it completely decentralized, so effectively empowering the application owners to then go in and create security rules as needed. However, this comes with an inherent risk because you could have security rules created without really having an understanding the risk around what is exposed internally within the networks or outside to the internet. You could also have a hybrid approach where certain configuration gets managed by your central IT team, certain configuration gets managed by the application owners. However, the challenge with that approach is it's difficult to apply configuration at scale. We don't have a capability or a mechanism to go in and enforce security controls by default when networks gets created or application landscapes gets created. So this also becomes a challenge. Now, the approach that Microsoft took in their own journey to ensure zero trust security and enforce management of these VNets at scale is a combination of Virtual Network Manager and also leveraging concepts such as Azure policy to effectively make sure when landscapes and environments gets provisioned, we tag these environments accordingly, which then essentially feeds that information to Virtual Network Manager to go in and apply security policies as needed when these environments come on board. The other benefit that we have with this approach is that we are now solving this challenge with an intention of having a centralized set of rules and governance, also giving the application team the freedom they need to go in and create the policies that they need, the rules that they need, while ensuring we still have security for essentially high risk ports. And also, we still have the ability, if there is a ransomware attack or there is a specific port that we need to quickly go in and patch or quickly go in and block across the entire environment, we have the tools at our disposal to go in and do it. So this is again one example how we've approached this problem and how we've been able to solve this using a virtual network manager, allowing you both the scalability and also the ability to maintain governance and security posture across your environment, whether you have thousands of VNets or whether you have 10 VNets, 50 VNets, you can still apply these principles. So with that in mind, I'm going to also talk about the different challenges that we see as customer environments grow, as we have number of VNets, number of applications gets added to the environment. What we see is if you are not using a centralized approach to manage your security, a centralized approach for managing connectivity, a centralized approach for managing um, routing, what we see is that the operational cost and the complexity will increase gradually. So, what are we going to talk today? Together with my colleague Deepak, we are going to look at what is virtual network managers. Just going to do a really quick introduction to what it is. We are then going to have a look at how do we establish connectivity, how do we establish routing at scale, not just for a single region, but how do we scale this out to number of other regions as needed in your organization. I'm then going to look at, now that we have built our connectivity layer, we have built connectivity for all of the VNets, all the networks in my cloud environment. How do I now ensure I can enforce the right guardrails at scale, not just for one region, but across the entire landscape, across multiple regions in my environment? Now, that is all good from a security point of view. It's all good from a connectivity point of view. But what are the tools that we have at our disposal to also understand how traffic passes from one VNet to another VNet? How do we verify network changes before and after changes are made? That is where network verifier would come in. And we will also talk about how verifier can benefit your current environment. And last, what we are going to do is we are going to run through few scenarios, have a discussion, and then we will wrap up the session with a quick summary. So with that in mind, I'm going to introduce Virtual Network Manager. So Virtual Network Manager, as mentioned at the start, the focus is to solve connectivity, solve security, solve routing challenges at scale. So this is an automation approach as well as a security approach that we can leverage on top of the existing fundamentals that you already built in your environment to be able to help manage your environment at scale. So we start off with this concept of a network group. So this allows you to group your existing networks or subnets into a virtual group. The grouping then allows us to layer different configurations, whether it is connectivity configurations, whether it is routing configurations, whether it's security configurations. We can apply different configurations against these virtual groups that you've created. And then what we have is in each of the configuration settings, be able to apply how we will allow connectivity between these VNets, whether we should establish a hub spoke approach, whether we should establish a mesh approach. How do we ensure security rules? What sort of source destination ports should we allow? What sort of security configuration we should deny? We can manage that through our security configuration we deploy against these virtual groups that we create. And then Virtual Network Manager also offers additional capabilities such as Network Verifier, allows you to verify your changes, as I mentioned, and also gives you the ability to manage your IP addresses across your environment within Azure, as well as you can onboard IP addresses that you use on premises and essentially have a single view as to how these IP assets are utilized within the cloud platform. So with that, what I'm going to do is I'm going to quickly recap the capability of a network group. So as I mentioned, it gives that ability to group your existing virtual networks. You can use either a static assignment. So you can say whenever you create a virtual network, you're attaching it to an existing group. That's a static assignment. Or you can also create a dynamic assignment, which could leverage multiple capabilities, such as a tag that is assigned to a VNet. So whenever a VNet has a tag environment equals production, we can automatically attach the VNets that are created to a network group. Or we can say any VNet created in this particular subscription, this particular resource group, or has a specific naming standard. We can also group all these VNets together, part of a single network group. So this allows to then attach different configuration, either connectivity, security, or routing, based on how we've grouped the environment. So with that, what I'm going to do is I'm going to invite my colleague Deepak to walk us through the connectivity capabilities and show us, how we can leverage connectivity features within Virtual Network Manager to automate the configuration and have a seamless management across your entire cloud landscape within Azure. Deepak, over to you.
Introduction. Hi everyone, my name is Deepak Maheshwari. I'm a cloud solution architect with Microsoft, based out of Perth, Australia. So I will be talking about the capabilities like connectivity, UDR, automation, and I'll just quickly give you a bit of understanding in terms of what kind of capabilities we can unlock using the AVNM. So AVNM makes different topologies much easier. So for example, if you want to use traditional hub and spoke, yes, you can deploy it. You can designate which VNet is a hub, and you can dynamically create spoke networks, and they can all be connected to the hub. And if any new VNet comes in, and if it meets the condition, it can be part of the spoke. We also have got mesh connectivity model, and we are seeing a lot of customers are demanding for it. The reason is sometimes they need to have non-prod environment communicating with each other, and they don't want to route everything through the firewall. Similarly, in some of the prod environment, they want a faster and quick connectivity, and you can achieve it using the mesh topology. And AVNM makes it much easier to implement, and I'll show you and talk about it more when I show it in the demo. The third one is the hub and spoke with direct connectivity between the spoke. So this is a different model as well. And in this model, you have got hub and spoke, which means if you need to communicate across the region, or if you are communicating outside your network, you will go through the hub. Within the spoke, you can communicate with each other using the mesh topology. So there are different topology options which are available for you to pick and choose, and you can decide for different network groups what model you want to implement. We also have introduced a concept of connected group. So this is kind of a new concept. Instead of creating mesh between the VNets where you have got multiple peerings, VNet 1 peering to VNet 2, VNet 2 peering to VNet 1, or maybe VNet 1 is now peering to VNet 3, 4, 5, and they all are peering to each other. So you would see like a lot of peering within your network configurations. If you're using AVNM, it will just bundle all those VNets as part of a connected group. So connected group will be like a one connected group of VNets which are having that mesh topology implemented on top of that. And we can see it if we actually have implemented the connected group. So if we are using the mesh topology, and if we go to our virtual machine and try to look at the effective route, now in this example, we can see that we have got connectivity, which is local, which is virtual network. Then we have got VNet peering, which is actually my hub. And then I've got another kind of peering type, which is like next hop type. which is the connected group. So you will see it. It means this VNet or this VM is part of the VNet, which is actually part of a larger connected group. Now with AVNM, it also gives us the capability to define different scenarios. So as we talked about, like sometimes you want to have your production environment only talking to production environment and your dev environment only talking to dev environment. So one way is you use hub and spoke, you create the routing, you configure through the firewall and NSG, and you make the restriction. Now, sometimes dev team really wants the faster and quick communication. They are doing some testing. They don't want to go through the change management, reaching out to firewall team, getting some of the ports allowed because they know some of this environment is local and they need to communicate with each other. And with AVNM, it is much simpler. So we can actually use something called tags. And with the help of tags, we can actually create the network group. And then based on the network group, we can have different configurations applied to them. So for example, if the non-prod networks need to talk to each other, they can communicate. If they need to talk to the prod network, then they have to go via the firewall. If they need to talk to internet, they will go via the firewall. And the same thing can be applied for both prod, non-prod, UAT, different kind of groups. If you want to create, you can simply do it with the help of AVNM. Now, other capability which AVNM provides, that's the UDR management. So we all know if we've got hub and spoke environment, every time we need to communicate between two different VNets. So we will be using like a firewall as a router, and we'll be routing our traffic through the firewall. Now, in order to achieve that routing, we need to create the route tables. So sometimes it's quite complex if you've got hundreds and thousands of VNets, and you want to create UDR for every VNet whenever it comes in. So it's a very painful process to manage it at the scale. Now with AVNM, what it provides, it allows you to actually define your configuration. And as and when new VNet comes in, it meets those conditions, it automatically gets the UDR applied directly to that. So that's something which UDR automation provides to us. Now, I would just quickly cover some of the basics before I actually jump on a demo and show you how does it all look like in the action. So when we configure AVNM, we have these three concepts. One is the network group, and network group is like you want to create a grouping of your network. And this grouping can be static, like you can pick and choose which VNet you want to add in the group, or it can be dynamic. You can say, I have this condition. If the VNet has got this tag, then it can be part of this group. If it has different tag, it can be part of a different network group. So you define the grouping of your networks here in the network group. And you can do it based on the VNet, or you can even do it based on the subnet as well. The second thing is configuration. So configuration is pretty much like I have the group. Now I need to define, do I want to deploy a routing configuration, or do I want to deploy security configuration or the connectivity configuration? Now, even within the connectivity configurations, I can even define, do I want a mesh kind of a configuration? Do I just want hub and spoke? Or do I want hub and spoke with mesh as well? So all those configurations, you will do it in the configuration. And the deployment is basically your goal state. So you have the configurations and you select that configuration and you deploy it into that region, and it will just make it as like goal state. Now, what will happen if a new VNet comes in and if it has got the right tag or right configurations, it will become part of a network group you have already defined, and it will automatically have the configurations applied and deployed on itself. So it will all happen automatically. Now, just to simplify, I have created a demo environment. So what I have done is I have got 3 different regions. Just to give you an understanding, if you want to scale it, it means we've got like a lot of regions in the environment. We might want to create the VNet peering between different regions. Maybe every region has got multiple spokes connected to it. And let's say we want to create a mesh topology between the hubs, because we would need a way to communicate between the hubs. So it's like kind of like global peering. And then we also need peerings from each and every spoke connected to their respective hub as well. And then we can simply go ahead and implement the configuration. So that's what I've done in my lab. And what I'll also do is I will try to deploy a couple of more VNets, and then they will automatically peer into the environment. So that's what I'm going to do in my demo. So let me just quickly move to the demo and show you how does it look like in the action. Right. So I'm on my Azure portal. Creating AVNM is simple. You go fill in the details. You define what kind of features you want to enable, like connectivity, security admin, user-defined route, and you just click next, and it will create a AVNM, resource for you. Once you have that resource, you can even see what kind of configurations features are enabled for me. So I'm using connectivity, security admin, and routing. It's already enabled for me. The next thing which I'll do is I'll create network groups. And to simplify this dev environment and to make sure I respect everybody's time, I have already created the network group. So creation of network group is very simple. You just click, fill in the information. You define you want to create the network group based on the VNet or virtual network or subnet. So you can pick and choose. And once the network group is created, you can actually go in network group and you can configure different membership options. Like you want it dynamic or you want it static. So if I click on this network group, it opens up my network group configuration, and I will be able to pick and choose what I want to configure in this one. So it shows me it has got 3 group members. So probably I will select group members, and I can see it has picked up different hubs because I have configured a policy. And I can click on here, and this should show me which policy it is currently using. So if I want to look at policy configuration, I can have a look at it. So policy is already applied. It looks at the VNet type field equals to hub, and if it is there, it will make it part of the network group. So that's exactly it is doing. So my policy is basically looking at it and then adding it into the network group. So all hub VNets is the name of the policy in the group of the network group, and with the configurations, it basically allow all the VNets to be part of this network group. And this is dynamic, right? And if I want to create more, I can simply click create, give it a name, select the conditions. Do I want to use tags? And in my case, like I'm using key value pair. So I'm going to give the conditions and, what's the key, what's the value. And that could be, the configuration. And if I want to make it more complex, or if my environment requires a little bit of, more configurations or complexity, I can simply use and or rule as well. So I can also do it. And if required, I can just write all these things as a code as well. So if I have got this configuration already in place, if I need to rinse and repeat, I can simply just paste the code here, and it will allow the configurations to come in. Now that's done. I have got different configurations. One is for my spoke VNets for each region. I have got one for my hubs, so they can have a mesh topology. And I have also created a group for my route table, which is going to apply to the firewall. So I can create groups based on my requirement, because I will be applying my configurations on my group. So that's why you need to have groups based on your requirement. Then next thing comes in the configuration. And in the configurations, I could see what configurations I have done. So if I click on in here, it simply shows me it is the mesh topology. And I have got my global mesh enabled, and it is getting applied to the network group. And it is applying to the network group, which has got 3 members in it. And this is the name of the network group. So it's very simple. I can add more network groups if I want same configuration to apply to multiple network groups as well. So I can simply do it. This is my another topology. So if I look at my topology, it tells me this is my hub and spoke topology. And if I look at it here, it will show me this is my hub. So this is the name of the hub. By any chance, we want to change the hub, you can click on it here. It will show you what are the VNets available, and you can change the hub as well. So all these things are configured. The next thing is deployment. So you can even see it shows the deployment status as deployed. If I come here, look at the deployment, deployment is very straightforward. It's a gold state, right? I can select, do I want to deploy my connectivity configuration, or do I want to deploy my security admin rule, which Nirmal will talk about, or do I want the UDR automation? So any configurations which I've created, I can deploy it. So if I select connectivity configuration, I've already deployed it, but take an example, if I select it and click on the regions where I want to deploy, I can click next, and it's going to tell me it's going to make some changes, which I don't want right now. So I will skip it, but that's how I have kind of deployed the configurations in this environment. Now, once the configuration is deployed, what happens is you've got the virtual networks, which will get the configurations which are deployed to them. So if I go on my hub virtual network, now if I look at the network manager, it will show me, what kind of topologies are applied to it. So I can see I have got the mesh topology. So this is related to my hub-to-hub communication. And the second is my hub-to-spoke, topology. And similarly, I can go in my spoke virtual networks. And if I look through the network manager, it shows it has, made this VNet part of the, hub and spoke topology as well. So if I create more VNets, what will happen? They will automatically start getting those topologies applied to them. So if I quickly run my script, I'm just going to add more additional VNets, which will deploy more VNets in my environment. And what will happen? I would be able to see them quickly in my network group, and then they will have similar configurations applied to them at the scale as well. And similarly, if I go and look at my configurations, so I've got the routing table. And if I look at my route table, I have rule collections which I've created, where I've clearly defined, which target network group these should be applied to, and what is the configurations, applied. So for example, if I look at one of this, I can even edit it, and I want to enable spoke-to-spoke communication. My network is 10.0.0.4. Anything which is 0.0, it should go to firewall IP address. So that kind of configurations I've done. If I add more configurations and add it here, then I'll have to redeploy my configuration, because it's not gonna automatically update it. So I'll have to redeploy my configurations as well, and it will show you in the configurations in deployment that it's not fully in the sync as well. So that's how I can do the route automation. And if I look at my virtual networks, so probably if I go and look at one of my spoke, and if I look at my subnets, it shows it has got the route table, which is AVNM managed. So I get that information that it's the route table deployed via the AVNM. So I can verify it. This is deployed by AVNM, and this is the subnet it is attached to, because it's the same route table which is getting applied to multiple networks. So if I click here, and maybe if I try to refresh my, yeah, so I've got like another set of VNets coming. Sometimes it takes a little bit of time. So, it could take a little bit of time to get the configurations applied, because it gets it through the policy adds it. So it takes, sometimes few minutes to get the policy, directly applied as well. But once it's applied, I will be able to see them here. So maybe I'll come back to this one during my network verifier configuration, and I'll show you that the policy is being, applied there. So with that, I'll hand it back to Nirmal to talk about security configurations.
Awesome. Awesome, Deepak. Thank you so much. I think really good demonstration how we can implement complex topologies and also at the same time automate all of the routing as well as all of the connectivity configuration at scale across regions. Now, once we've set up our network, once we set up our connectivity, the next aspect for us to look at is, how do we secure this? So this is where the security admin rule capability comes in, which is part of Virtual Network Manager. So the key thing to understand with this offering is that it is not the same as network security groups, which are essentially decentralized components that are assigned to either subnets or network interfaces. But admin rule offers you an additional governance and security capability that can be applied to your VNet utilizing security configuration we create within Virtual Network Manager. So let's have a look at what are some of the capabilities we have through security admin rules. Now, when you think about a network security group, if you look at the rules, these rules start at rule number 100. With security admin rules, we can create security admin rules higher in the order. So essentially from 0 all the way to 99. So what happens is any configuration we apply part of security admin rules will be processed first before we go in and touch the network security groups. So this is what is really allowing us to have that centralized management aspect, at the same time giving application owners full control over the decentralized portion, which is the NSGs that are applied to their workload. Now, security admin rules offer 3 types of configuration when you create security rule. One is, you can say, allow traffic to pass through and say this is a non-terminating configuration. So you can have set of allow rules. You can also have always allow rule, which is a terminating rule. Now, what is the difference? Now, if I have a allow rule in the NSG, and then later, if there is a deny rule, the deny rule will come into effect and make sure traffic gets denied when it's denied on the NSG. But if we have a always allow rule, what happens is the evaluation will essentially stop from that particular rule. So this is really useful if there are scenarios where you need to ensure from each VNet there is traffic that needs to go to maybe your management servers, maybe an antivirus server or some other server where you need to maybe send logs. You want to ensure that these ports are always allowed, regardless of what is that configuration in the NSG. So this is an ideal use case for this always allow configuration. The third type we have is a deny rule. So essentially, deny rule is a terminating rule, which would mean any sort of high risk ports, maybe an SSH port or an HTTP port, I can go in and deny through a deny rule. So this is the configurations that are available part of admin rule. Now, this is again a quick comparison between security admin rules and NSGs. So essentially, as I said, security admin rules effectively gets processed first, higher up the stack. with a higher priority. And then the NSGs are essentially processed after, and these are effectively living in your subnets and the NICs, ideally controlled by the application owners. Now, when we think about why do we need this, this comes back to the use case I shared at the start. When we have large number of VNets and a growing environment, we need to have a mechanism on how do we do 0-day protection or security by default. So whenever someone creates a VNet or an application owner creates a VNet, we want to ensure that the guardrails are set from the get-go. So as soon as these resources come on board, we want to make sure that these security rules are applied. The second thing is if there's a emergency patching that needs to be done, there's a certain port maybe that is now exploited. We want to go in and patch this particular port across the entire environment. And that's another ideal use case for Virtual Network Manager to then create that security configuration and then essentially apply it at the management group hierarchy that you have. And then any subscriptions, any other child management groups that you have, all of them will inherit this policy and then automatically would go in and deny traffic to these ports that we want to deny. So a common design pattern is we can have set of allow rules in security admin rules, or we can have a set of deny rules. So we have two different design approaches. So we can say certain allow rules to be configured part of my security admin rule. So this is essentially an allow rule configuration, or we can have certain things that we specifically deny a part of a security admin rule. So example, things like SSH or RDP type ports, we can ensure these are denied part of it. So again, two different approaches as to how we can design and also implement the security admin rules together with existing controls that you have in your environment, things like NSGs. Now, the key thing here is around how do we apply this? Now, one of the differentiations we have with Virtual Network Manager is that it is not a decentralized approach. Now, why I say decentralized is that the configuration for Virtual Network Manager is essentially applied either at the subscription or at a management group. So this really gives you that flexibility where you can apply these policies and configurations at a management group, and really doesn't matter the application owners having subscriptions because these subscriptions are essentially attached to a management group. So all the policies, all the configuration we set at the management group, very similar to how you manage your show policy today. You deploy these policies to a management group, and then any subscriptions, any child management groups that are attached to it will then essentially inherit all these policies by default. Also, the subscription owner will not be able to change this because we are applying this configuration at that higher level in the hierarchy and ensure all of these policies cascade, ensuring we have security by default in the environment rather than needing to apply other scripts or other things after the environments are created. Now, it's also giving us that flexibility. We can have certain set of controls applied at the management group hierarchy. Also, we have the ability, maybe there are certain use cases where we want to do some exemptions. We can apply that specifically at a subscription where the exemptions are needed, and then give the ability for certain exemptions to allow either access to the internet or access to certain other resources. Now, with that, what I want to do is want to go into a quick demonstration and demonstrate how this works. So in my environment in here, I have created virtual machine. I didn't follow any security guidance, so I went in, created a virtual machine. This virtual machine, I'm running a web application, and part of this application, so if I refresh this page, you can see that I'm able to access this application. So 109, 114, 115 requests. So I'm able to go in and access this particular website through this public IP. Now, this is an unsecure port because I'm accessing this website through port 80. So there's no encryption, TLS part of this connection. So any data that I'm essentially sending through, anyone can intercept, anyone can access that data because there's no security part of this connection. The other thing is the virtual machine I created has a public IP, so I can SSH to this VM and I can go in and access things that are part of this particular virtual machine. So this is essentially not ideal from a security point of view. So I want to make sure I am blocking access to these ports. Also, I'm blocking access to this virtual machine from the internet. Now, the way we want to approach this is by creating a network group. So Deepak covered, how we create these groups, how we can dynamically add VNets that we create, part of a policy, and the policy then creates a group. So in my environment, I've already created a network group in here for production apps. Now, what I will do is I will walk you through the configuration I have. So this is a security configuration, essentially to block a high-risk port. So what I've done is I've created a high-risk port blocking rule, and then part of this I have targeted this against the production apps. And in here you can see there are two rules that are being created. So one is for HTTP, the other one is for SSH. Now let's go ahead and quickly deploy this in my environment. So I'm going to say I'm deploying a security configuration, and I'm selecting the high risk ports as the one that I want to deploy. And then I'm going to target a specific region that I want to deploy. So here you can see I'm deploying this now. Now, part of these deployments, it will also show me, if there's any existing deployments in the environment as well. And then if there is any existing deployment, it will show me what is going to be removed or what is going to be overridden, because each time you do a deployment, that is essentially the goal state for that environment. So you can see it took only a few seconds. The deployment is done. Now, what we expect is like we try to access the website, we try to SSH to that virtual machine, my request should be denied. So with that, what I will do first is I'm going to try and see if I can SSH. So you can see the SSH request is denied now, not able to connect to it anymore. And if I essentially try to refresh, you can see that my web request is also not passing through. So we've been able to apply the security configuration at scale for large number of VNets in my environment. And we were able to do it within seconds by configuration that I had created, and it effectively goes in and applies to all of the VNets in my environment. Now, a common question that comes in is, how do we troubleshoot this? Now we know that, we've applied the config. We know that the traffic is secured. All the high risk ports are blocked. But what kind of visibility are we providing? Now, from a visibility point of view, if you have virtual network flow logs turned on, it will show you why the packets are getting dropped, like what rule is used for blocking that traffic. But outside of it, if you move on to the virtual machine, there are two places where we will show what policies are applied. First thing is in the VM, you can navigate to Network Manager. And in Network Manager, we now have the configuration tab, and we also have a security tab, which will then show you, okay, there is security admin configuration now applied part of my virtual network manager deployment, and the user will be able to see that there are these rules that are applied. They cannot change or they can delete this. This is just giving visibility that, this is the reason why you're not able to access this from the internet, or not being able to access this website using the unsecure port. That's one way to look at it. The other way to look at it is when you go into your network settings, you open up your network interface. If you scroll down to your security rules, that's another place where you can have a look. So in here, again, give you visibility. You can also download this into a CSV file and further look at what kind of rules are applied in the environment. But we also give a visual representation to say like this is the associated NSG, and this is the associated virtual network manager. And if I click on the virtual network manager, again, same view like in the VM, I can also see what are the rules that I applied. So that's a really quick demonstration how we can apply this configuration at scale for our environment that is already deployed in our environment, or whenever new VNets come on board, we can ensure that we are making sure that the security posture you want to maintain is standard across all the environments in your landscape. So with that, I'm going to hand over to Deepak to walk us through about virtual network verifier. Deepak, over to you.
Thanks, Nirmal. So yeah, I'll quickly talk about virtual network verifier. So this is a new capability which has been recently added in AVNM. And what it essentially does is it basically lets you simulate and validate your network traffic and communication. So if you've got NSGs, you've got firewall, if you've got route table, all of those things in place, it can help you validate if the communication was stuck at some configuration. So for example, if you've got NSG which is dropping the traffic, you will be able to see it with the help of network verifier. So that's the goal of network verifier. And the benefit of this network verifier is that it helps you validate your network configuration. So you can do it pre and post configuration validation as well. So let's say you are implementing some changes, maybe introducing a new firewall, and you want to verify the communications before you bring in the firewall. And then you can do the another test, and it can tell you if the traffic was allowed or not. Those kind of verifications you can do. It allows you to do the debugging. It enhances your network management because now you have the visibility, and you can also delegate the control. So let's say you have a scenario where application team wants to get confirmations whether they are able to communicate between two different VNets or not. You can actually delegate the verifier workspace directly to them, so they can even create their own test and test the connectivity mechanism. It provides the detailed analysis and reporting. So every step it takes, it goes through those steps, and it basically confirms whether the traffic was allowed or not allowed. You've got full steps and visibility when the verifier is running. There are supported features for this reachability analysis. So things like if you've got NSGs, ASGs, network manager, security admin rules, your topologies at hub and spoke, peering, route table, service endpoint, private endpoint, virtual WAN, and Azure firewall, static L4 only. So if you have a firewall in between your virtual network, and let's say if the firewall doesn't have a rule allowed, network verifier will be able to tell you whether there was any rule or not. So if any rule allows that traffic, you will be able to see that one as well. So that's the benefit of using the network verifier in the network. So there are different scenarios you can achieve. You create the network verifier workspace, and you create the intent. So there is a reachability intent you can create, which is pretty much like, I want to communicate between one VM to another VM. You select those VMs. That's my intent. I want to communicate over port 22, or maybe I just want to check the connectivity. You define that intent, and you run the analysis, and then it gives you the report. And you can keep rerunning it, and you can have a historical information in terms of how the traffic is going through, because if you're making any changes, you would need that historical information. As I said, you can also delegate it. So if you want to provide this capability to application users, you can even delegate the workspace, and application users can do it by themselves. So with that, let me just quickly jump on the demo. I'll just quickly verify, because I was doing the route and connectivity automations. So maybe if I just refresh, I had 2 virtual networks here. Now I could see these are 4 because I recently added new virtual network. And if I go on those virtual network, I'm able to verify the configuration is automatically applied to them. So this is my spoke 3, which was not there, and I created it. So part of the last demo, where I just wanted to give you the claims that yes, if you deploy more and more VNet, and if they are part of the network group, they'll have the configuration applied to them. Now, this is the network verifier. So to get started, you need to create a workspace. So verifier workspace can be created. You can create multiple workspaces, and then you define what is your intent. So what is your reachability analysis intent? Now, in this case, I've created a couple of intent. The way you create is you just provide the create information. You fill in some details like what's your protocol you're going to use, what's your source, is it going to be virtual machine? If it is, you select that virtual machine, which is going to be destination, what port you want to communicate to. If you select a VM, it automatically fills in the IP address for you. So to save time, I've already created a couple of reachability intent. So maybe the way it works is you click on start analysis, give it a name, and then this analysis will run. Now, It takes a couple of minutes to run the analysis, but you can see the result. And if you run it again and again, you will see multiple results. So if I look at my view results, what it shows me that my traffic was, communicated. Now it's giving me that graphical kind of, configuration, and it's clearly telling me that my virtual machine went through the network interface, it went through the virtual network. And if I had NSG here, I would have that information as well. So I would not have that showing it here, but I would have it as part of my JSON output. And then it communicated to the private endpoint. So the private endpoint, which was created, and directly connecting to the storage. So it can help me verify if I'm even using the private endpoint or not. So it kind of gives me a graphical, user interface to confirm those details. Now, if I want to see that information in a JSON output, it kind of provides me all those information, like what happened with one step, which network interface card, it was able to hit, then what happened. So it is essentially, delivering the packet from one end to another end and confirming if it was delivered or not. So here I could see the packet was delivered. If I go to my next one, so maybe I'm communicating between my virtual machine and I want to see the result if I'm able to communicate, because I've created both hub and spoke and mesh topology in my environment. So if I click on view result, it shows me, my all the packets were delivered, and I don't see any firewall here. The reason is because I created a mesh topology. And with the help of network verifier, I was able to verify that it's only communicating through the VNet. I don't see any firewall in between. If I was using hub and spoke only, then I would see the firewall here. And it gives me a JSON output, and I can read it. So just to make sure I've got that JSON output here, just to show you, it shows me it picked up the next hop type as connected group. So as I have got the mesh topology implemented, it basically provided that information for me. And I can look at how this traffic went through if I need to provide this information back to somebody, or maybe let's say I'm building some sort of automations using this capability. I can look at the result. I can look at the explanation. It gives the traffic matched. It was allow if there is a UDR, if there is a NSG, which NSG rule did it use in order to communicate further, or maybe which NSG rule blocked that traffic as well. So I can get that kind of detailed information, which I can use it in order to kind of troubleshoot any network connectivity related issues. Right. So this concludes the demo. I'll just quickly jump on to the summary. So we have gone through the AVNM capability, and we have seen that it provides the centralized network management. So we can have different configurations in place. We can create the network groups, and we can apply either connectivity or security or routing configuration. It also helps us, implement the UDR management at scale. So if we want to manage UDR from a centralized console instead of creating multiple UDR, it's a one-click deployment. And our configuration using the dynamic membership will allow all VNets to follow based on the conditions we have defined. It provides us the connectivity configuration. So if you want to have hub and spoke, or maybe mesh, or hub and spoke or mesh, again, depending upon your dynamic, network group membership, it will apply those, policy on them. It also helps us implement the, admin rule. So security admin rules, if you want to apply consistent, high priority network security policies across the environment, we can do it through the AVNM. And it also gives us the capability to verify and simulate our network traffic reachability. And it kind of confirms whether the traffic was actually, whether the data was delivered, to the destination or not. If not, where it got stuck. So I can troubleshoot at that point. Sometimes it's hard to know if you got NSGs, firewall, UDR, everything in place, like what is missing. Now, with the help of Network Verify, I can clearly see, oh, okay, the traffic moved from NSG, it hit the firewall, and after that, it's not connecting. That means the problem is the other side of the firewall, not before the firewall, because it was all allowed before that. So it gives that kind of visibility. So with that, I think we are done for the session. If you guys have any question, feel free to put it in the chat window.
Thank you so much for such a great session. And thank you to our viewers at home that joined us today. If you happen to miss any part of the session, you will be able to rewatch this entire recording on the Microsoft Reactor YouTube channel in 24 to 48 hours. Thank you guys. Let me pop Nirmal really quick. Thank you guys so much for such a good presentation and for taking some of your time to talk to us about this very interesting topic. But it looks like we have no questions in the chat, so I will be wrapping up the session now. Thank you guys once again. And I just want to show our community that we do have a Discord and GitHub community in case you guys want to scan the QR codes and join the community here at Microsoft. We would appreciate that very, very much. But aside from that, thank you all, and we hope you have a wonderful rest of your day. See you guys.
Awesome. Thank you all. Cheers.
Cool. Thanks all. Yeah. Bye.